Did you ask me a question? Oh, I just said, are you asking me a question? You said yes. No? Okay. All right. I don't know. I didn't eat lunch, so maybe that's part of my problem here. Okay, guys, I'm recording. Let's get started. All right, let's start with number one. I was able to get this done in 2 of the 3 classes so far. Please try and stay with me, especially when we do a lot of the calculator steps, because there's not going to be a ton of extra time to like go fix the screen on your calculator or whatever. So when I do a calculator step, I'll be very clear about what I'm doing, because a lot of these questions are just how to put it in your calculator, and you have to do it correctly for obvious reasons. So when I do those problems, please just make sure you're doing them with me so we don't hold up the class, okay? But again, if you really fall behind and you need to start over with me tomorrow, we could do it in class, okay? All right, so let's get started. Determine which of the following is a vertical asymptote to this graph. So tan has asymptotes at negative pi over 2 and at pi over 2, okay? If this were a cotan question, cotan has asymptotes at 0 and pi. So the steps are exactly the same for whether this is tan or cotan, except the asymptotes are different. So to do either one, we grab our argument, which is whatever's in the parentheses, and we put it in between the 2 asymptotes. So since we're working with tan, we'll use pi over 2 and negative pi over 2. Okay? And we're going to solve for x. I'm going to start off by adding pi over 2 to all sides. I'm sorry, that's not the right. What's that? That's what number is this? So 3? Pi over 3. Thank you. So pi over 3, adding pi over 3 to all 3 sides. Okay? Since they're different denominators, I'm going to go find some space to do common denominator stuff. So I have pi over 2 plus pi over 3. Common denominator would be 6. 3 times 2 is 6. Pi times 2 is 2 pi. 2 times 3 is 6. Negative pi times 3 is negative 3 pi. Show as much or as little work as you need to. But you would get negative pi over 2. Okay? And then over here, same thing. Pi over 2 plus pi over 3, denominator of 6. 5 pi. Is that what you said? Negative 3 plus 2 would be... What? It's a... Thank you. Gosh, keep an eye on me. All right, and so this would be 5 pi over 6. Sorry about that, guys. Man, I'm recording this. Sorry to the people watching this video. I apologize. But yes, it's a denominator of 6. All right, but we're not done because we have to divide by 2. So remember, dividing by 2, okay, fine. But when I go to divide by 2 with my fractions, I would have to multiply by the reciprocal. So I'm just going to do that instead. And I would get negative pi over 12 is less than x is less than 5 pi over 12. So which one of those is one of my asymptotes? That would be 5 pi over 12. Okay? If you missed Friday and haven't caught up yet, there's 2 questions on this test that have to do with secant and cosecant. And the reason I'm bringing that up when there's absences every day is because we never saw it again, and we'll probably never see it again. So we did it for 1 day, and that was it. We didn't review it really yesterday or anything. So here's a quick lesson, but if you don't understand this one and the one we're going to do in a little bit, you need to go back and catch up on Friday's lesson. So we learned that secant is friends with cosine, and what they're asking here is, where is secant undefined? So let's first sketch a graph of secant. And to do that, we would start by sketching the skeleton graph, which is his friend cosine. So I'm going to break up my x-axis into 4 equal-ish intervals. And then I remember cosine is up, middle, down, middle, up, right? And everywhere that I have an x-intercept, I have a vertical asymptote, and then I have curvies at all of my mins and maxes. And this repeats, right? Right now, I just went from 0 to 2 pi. And anywhere that my graph has asymptotes, those are considered undefined, right? That's where there's no point. You can't put a point there, so we block it by putting an asymptote there. So we need to know what these two angles are. So we're going from 0 to 2 pi. Right in the middle would be pi. And then in the middle of those two would be pi over 2. And in the middle of these two would be 3 pi over 2. So two of my angles are pi over 2 and 3 pi over 2. Well, that's only from 0 to 2 pi. But you can, without having to do the work, you could imagine that it just repeats to the left of 0. So that would be negative pi over 2 and negative 3 pi over 2. So that would be choice B. Okay, so asymptotes are where our graph is undefined. Okay. Where are all the values of theta on the unit circle for this equation? So we're basically solving an equation. So anytime you're solving a trig equation and you kind of don't know where to start, one thing you can do is change the word, like in this case cosine, to a variable. Pick a variable. If there were two different words, like if it had cosine and sine in it, you could make one an x and one a y. But like this would be like 2x squared equals x. Think of it like that. How would I solve that equation? Well, it's like having the ax squared plus the bx and not having the c. I'm going to get all of my terms on one side together and then factor out a GCF. Okay? So I'm going to subtract cosine from both sides and take out the GCF. So 2 cosine squared theta minus cosine theta has a cosine theta in common. Cosine squared theta just means 2 cosines. There's 2 of them there. Okay? So I'm going to take cosine out of both of these. You don't have to do this work, but this is essentially what I'm doing right here. And I'm dividing both terms by cosine theta. Whatever's left goes in parentheses. It's the reverse of the distributive property. So I would have 2 cosine theta minus what? 1. I asked that because I keep seeing people get that wrong. Okay, if you want to check it, it's just the distributive property. You could distribute to the parentheses and you would get what's written above it in green. Okay, once you get to this stage, you can just set each of these equal to 0 separately. So I have cosine theta equal to 0, and there's nothing to solve there. And I have 2 cosine theta minus 1 equals 0, and I can do a little bit of work there, right? Add 1, divide by 2 to get cosine by itself. Add 1, divide by 2. So let's see what our answers are. So this is pure unit circle knowledge, right? So I'm feeling vibes of quadrantals with this guy, with cosine being 0. Of course you guys are back there talking, come on, gosh, shouldn't I supposed to be sitting together? 0, 1, and 0, negative 1. Where is cosine 0? At the top and at the bottom. Those are pi over 2 and 3 pi over 2. Where is cosine 1/2? What are those denominators, y'all? Denominator of what? 3. And where is cosine positive? 1 and 4. So pi over 2 and 3 pi over 2 and pi over 3 and 5 pi over 3 BB. Okay. All right. Find the general solutions. We saw that word before. It means the same as all. Find all solutions. Okay. So I'm going to get tan x by itself. Subtract 1, divide by the square root of 3. subtract 1, divide by the square root of 3, and I don't recognize that, which means I need to rationalize the denominator. So I know that denominator. That denominator would be what? 6. Now, this happens twice on the unit circle, but if you look at your answers, sometimes your choices can help guide you, right? Why is there only 1? Oh, that's right. Tan has a period of pi, so we only have to list the first one, okay? So where now do I see that tan is negative? Of course, quadrant 2 or quadrant 4, right? 5 pi over 6 plus pi, however many times you want to find it, because it's every pi, both directions of n. Okay, so you can see how close these two answers are. Be so careful. Like, to know that work, not that that's difficult, but knowing that and knowing the answer and then choosing C and getting no partial credit, it hurts my heart, okay? So I know I keep saying it, but there's benefits to multiple choice with no partial credit, and there's non-benefits. Some of you can kind of use your brains to narrow down the answers and kind of figure it out. Like, some of you might even be able to look at this and say, I know the answer is A or C, or I'm sorry, A or D, right, because of the pi, and maybe get a 50-50 chance. You don't have to show any work, so it's good. But at the same time, you might have done all the work and then picked by accident the wrong one. Let me know again, Arlen, is that happening? All right. Here's the other one that was secant and cosecant. Okay. Cosecant is friends with sine. And the question is, what is the range of this function? So I'm a visual person. I can't just do it abstractly in my head. I'm going to just sketch a period of cosecant, and then I'll come back to the question. Okay. So again, I'm going to start out by graphing sine. Sine is middle, up, middle, down, middle. How did I know to keep that pattern? Because k is greater than 0. That's k. If k is positive, it's just middle, up, middle, down, middle. That's the pattern of sine. And then everywhere I have a x-intercept, I have that asymptote, just like the other graph. And all of my mins and maxes have that curvy on them. Okay, so there's one period of the graph of cosecant. Now back to the question. What is the range? Okay, range is my y values. So see where k is right after the equal sign? That's like my amplitude. It's not technically called amplitude, but we can kind of think of it as that. So this is k and this is negative k. So whenever we read our domain or range, we always go least to greatest. So these arrows are pointing down. So that's negative infinity up to negative k. Is there going to be a bracket or a parentheses on my negative k? Bracket. Yeah, we actually have a point at negative k. Doesn't have to be touching it, just we use that value, whatever it is. Union, that's like, let's take a little break. Oh, we jump back in at k to infinity. So again, the choices C and D look really, really similar. Be careful that you pick the one that's got the brackets. Okay. Good so far? All right, we're getting into the calculator stuff, so this is where I really need you to stay with me. Okay. Also, for a couple different reasons, staying with me is when it comes time for test day, I can't help you with your calculator. You know, I always have students that are like, no, there's an error and I know I did it right, fix it. Here. I did it right, I know I did it right, and there's an error. But that can't be true, okay? It's for me either. If there's an error, that means I made a mistake. The calculator didn't make a mistake, okay? I made the mistake. So and some of these are very particular about how we put them in. So let's practice these together. For sure, you want to clear your RAM, because on all these problems, we're changing the windows. And trust me, if you try to keep old windows in with a new function, it gets so confusing, even if you think you can go in and change them. So every single time I do a new one, I clear the RAM. Okay? Now, let me read the question to you. And I did this question a few times, and I have no problem admitting my faults to you guys. It's good for you guys to know that I'm only human too. But the truth is, I didn't read this carefully enough. So let me pass on my mistake. We can learn from each other's mistakes. The monthly profits, T in thousands of dollars, that's where I messed up, at a winter ski resort are approximated by the function T in months, where T equals 1 corresponds to January. Determine the time from 0 to 12, so basically the first year, where profits are $100,000 or more, okay? So they give us a cosine function that we'll type in, and we're going to do an intersection of 100,000, but that's where I messed up. I just read the problem just like it says, and I kept typing in 100,000 here, and I couldn't, for the life of me, find the intersection. I spent way too much time playing with my window and trying to find it, and it wasn't there. I couldn't find it. And then I sat down and I concentrated and I read it better. Just kidding, I went and asked Ms. Springer, and she reminded me that it says in thousands of dollars. So what, instead of 100,000, do you think I should have typed here? 100. Yeah. It's slipped in there. Sometimes it says that stuff and doesn't even matter, right? It really mattered in this problem. So it's a word to the wise, us, that we have to really read these questions, okay? You know number 6 on your test is going to be just like this. And there's going to be someone that says, I typed it in, you can look at it, and there's a mistake, I can't find, and it's not the calculator, okay? All right, so let's go ahead and type this in. Now, you should all be typing at this point. There's something else that's very picky in this problem as well, and it's coming up in the parentheses. So in my parentheses, so when I hit cosine, it opens the parentheses. Guess what? My numerator's got 2 operations. It's got multiplication and subtraction. If there's even one operation in my numerator or denominator, I have to separate it by its own set of parentheses, okay? If you don't put 2 sets of parentheses here, it's not going to work, okay? And I'll explain why more in a second. So let me go ahead and type it in. Everybody should be typing this. Close those parentheses. And I'm going to hit enter anyway, so I can either double close them or I can just hit enter. Or I'm going to actually go down here and put 100. So the reason we have to do that is this. So just understand what I'm about to write here is wrong. So if I didn't put in the parentheses, what I would be telling my calculator to do is pi times x minus 4/6. Okay, that's very different than that. We want the whole numerator done, then divide by 6. And your calculator doesn't know that that's what you're seeing. If you type it in without this extra set of parentheses, that's what your calculator reads. Okay? And then we have 100. Now, I'm not going to waste time hitting graph, because I already know my window is going to be way off. If you go to window, remember, when we... What? And I never divided by 6. Right, I was going to, and then I forgot. And this is where I should have said I could close the parentheses or not. It doesn't really matter because I'm going to be graphing it. Thank you, Jordan, for catching that. That would have given us all a big headache right there. Okay, so I went back in and put the divided by 6. So my numerator is in parentheses, the whole numerator divided by 6. Okay, now before I hit graph, because I'm not going to see anything. Remember, when you clear your RAM, we default to 10 in all 4 directions. Well, we already are asking it to tell us up by 100, so 10's not going to do it. And then look at your x values. Okay, they're like between 0 and 12. Oh, I should have known that also from this right here. So I'm just going to change that to 0 to 12. Okay, so my x min is 0, my x max is 12. My y max, we can go up to maybe 200, 150. Sometimes I pick a number and it's not to my liking. I might go back and change it. I honestly don't remember what I did earlier. 150 might be good. I might not like it. I might have to hit 200. But remember, sometimes with the intersection, there's not one answer. I should say 100% of the time. There's a lot of different y maxes you could get. As long as you can see where they intersect, that's what matters. Okay? As long as you can clearly see and get on both sides of your intersection. So understand what we're looking for. We're looking for where our curvy graph is at or above the red line. So that's going to be from 0 to that intersection, and then from this number to 12, right? So we can use our intersection. So under calc, go to 5. We've done this one 5 million times. Enter, put on either side of it. Remember, it doesn't have to be really perfect. And you'll get x equals, and I'm glancing down at my answers. They're all in rounded nearest tenth, so I'm not going to spend a whole bunch of time rounding this problem, okay? And then find your other intersection. If there's one thing we should all be able to do on these calculators, it's intersection. I feel like we've had to do it on every single test. Enter, 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 and I get 10.7. So those are the two intersecting places. So remember, we went from 0 to 3.8, and then 10.7 to 12, and so you can see that would be, okay? So just be really careful putting it in your calculator, and then looking at your window. The window part can be kind of tricky too, right? We're going to have a couple more of those coming up. Okay? Thanks for being awesome. You guys are wonderful. I hurt you. Okay. Function f is given to us. Here it is. The function g is this. Let me read it. 2 times your f function plus 0.35. What are the zeros on this interval? Okay? So what are the zeros of g? So I'm going to be putting g in my calculator. So g of x would be 2, right, times my f function. So I'm putting it in parentheses. Close my parentheses. Plus 0.35. Okay? So I'm going to type that in my calculator. Again, I've changed my window. I want to clear my RAM and start over. Okay? So 2, parentheses, sine, and sine or cosine is always going to open up another set of parentheses, okay, which is fine. 2.5x, 2.5, because that's what it says anyway, plus 0.25, and then close my parentheses, and then plus 0.35. Now let's see what that looks like. That's too much stuff going on there. Let me now go back to my window and change my window to 0, my interval. Remember, interval means x-axis, from 0 to, use your pi symbol, pi. Okay, let's see what that looks like. Okay, zeros, what are zeros? Zeros are x-intercepts, solutions, x values. As long as I can see them, my window's good. I don't have to waste any more time with it, right? So zeros are at the same place as intercept. It's just number 2, okay? So, get on either side. So, enter, enter. Guess I get 1.299. Why? Okay, this is what I was talking about earlier, Ashley, when I was talking to them. Why am I getting that answer? 1.299. That is not the right answer. I what? But it's not. The answer is C. I did this problem first period, second period, third period, sixth period. I've gotten every other period. I've gotten a different answer, and I cannot figure out what I'm typing in here wrong. 0.3. I don't think that. I think I know what it is. I think I need a double parentheses here. Let me see. Plus 0.3. What'd you say? Let me try this again. So mad at myself. Enter. 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 Yeah. So here it is, and I just didn't take my own advice. So look, because here's the thing. It doesn't matter if I close the parentheses if there's nothing else after the parentheses here, okay? But since there's a plus 0.35, I have to end my thought. Think of it like that. So after the 2, I have parentheses. When I type in sign, it automatically puts parentheses. I have to close it twice. Okay? I have 2 sets of open parentheses. I have to close it twice because I have more coming after the parentheses. So I have to end that. That's what I did wrong. Okay? So when I graph it and I find my zeros, take a second if you want to. I'm just going to write them here. I should get 1.227, and then the second one will be 2.343. So make sure you don't forget double parentheses there. Important, important. Maybe I'll remind you guys on test day, since I kind of messed that up. I'll remind you guys, number 7, close the parentheses twice. Okay? Because I feel bad. Okay? We good? Ready to go on? So what are the answer was? Okay. Okay. All right. This would have been 3.10 day 4. We had already done 3 days of 3.10. Spring break was lurking, coming up soon. SAT, we had to move on. I knew I had one question on the test that had to do with inequalities, and I knew I would cover it with you right now. Super, super easy. Let me show you what we're doing. We're finding where sine of blah, blah, blah is greater than or equal to sine x. Back to our calculator. Clear your RAM. What you're going to do is put the left-hand side in y1 and the right-hand side in y2. Okay? Let me show you. Sorry? Were you using intersection instead of zeros? Okay. Yeah. So that last one was zeros, not intersection. Okay. So, guys, watch. I'm going to type in sine of x minus pi over 3. Over 3. Notice I don't have to close my parentheses when I'm hitting enter afterwards, but it's fine if you do. It won't hurt anything. Okay? And then sine of x. Okay? And I'm going to go ahead and change my window to 0 and to pi. And let's see what it looks like. Okay. So what I want you guys to see, and I'm going to zoom in better in a second, but first of all, I want to talk about this. If you're using one of the fancy calculators, you've got 2 different colors. I've got blue and then red. So my first one is blue, my second one is red. What I'm trying to see is where is the blue line greater than or above the red line. So I'm going to be finding intersecting. If you don't have this fancy calculator, you guys listen, you literally have to watch your calculator when it's graphing. You can't look away. You'll have to go back and graph again because you want to see where the first one is and then where the second one is. Now, even though I could do this on my calculator, find the intersection, I'm going to zoom in a little better for you guys. So I'm going to go to my window and maybe I'm only at -10 to 10. I'm going to change it to like -5 to 5. Just for teaching purposes, it makes it a little bit easier to see. Okay, so what I'm looking at is where is, on my calculator, blue versus red. So where am I above it, above the red? So from 0 all the way to whatever this intersection point is, blue is less than. Then from this intersecting point to this intersecting point, blue is above the red, and then it's below. So what I really need to find is what is this intersection and what is this intersection. And those 2 points, from this to this, is where my first part of the equation is greater than or equal to that one. So again, with my intersect, how many times I want to use it. So enter, enter, and you'll get 2.094. So let me just tell you, you get 2.09, and the second one is 5.24, which I'm sure isn't surprising. That's all the numbers that we have there. But how do we answer the question? Okay, so when there's a union, that's a break in it. So it's like it went up and then it went below and it went up again. So it's like 2 separate parts of the graph. So it can't be those 2. So it's one of these 2. How do we know if it's going to be brackets or parentheses? It's got the equal to. It's that tiny little symbol that makes the difference between C and D. We are greater than or equal to. So brackets is including those values. Okay? Good? Yeah. All right, last one of these before we get to our FRQ, which is really easy, by the way. The FRQ is really easy. All right, a 10-year study was conducted on the population of a herd of deer, P with respect to time, T in years. The total number of deer over time can be represented by this crazy function. All right, so I almost cut this problem off the test. I was like, oh, there's too much going on here. And then I stopped and said, you know what, it's not that bad, especially when I'm going to do one in the review for them. So what you want to look at is what your choices are, and then I'll explain how we put it in the calculator, what we're going to look at. So all four of these answers is analyzing the x-axis, T, between 5 and 6, between 2 and 1, okay? So you can see. So we're looking at what's happening at the x-axis, but what's going on with the rest of the graph? A minimum, okay, minimum number, is that happening at this time on my graph? Decreasing or increasing. When a graph is decreasing or increasing, it's literally going up or down, so that's the slope. A graph that's decreasing has a negative slope. A graph that's increasing has a positive slope. Don't forget what decreasing rate means. For both of those, that's concave down. Remember, if the rate is increasing or decreasing, remember decreasing down, D and D. And then this last one, again, is just going down to going up. So when I first started doing this, I was like, oh, it looks too hard. And then I was like, wait, it's actually not that bad, because you'll probably know your answer within the first couple, because then they all relate to each other. Let me show you what I mean. Clear your RAM. And let's type it in. So this one's actually not as bad to type in, believe it or not. 500 sine. And instead of using 1/4, why not use 0.25? Parentheses. Pi x, pi x, minus 2. Do I need 2 sets of parentheses? Yep. I do, because there's something going on after. Now, I'm going to go to my window, because there's no way I'm going to see anything when I graph this. I'm not wasting my time with it. I mean, we're so quick to hit graph, me too. But I'm asking it to go way, way up there. So, first of all, let's see my x-axis numbers. I'm going to just zero in on what numbers that matter. So, let's just say like from 0 to 10. Okay, I don't really care about anything past that, because I'm not evaluating. The graph could be going up and down for a really long time. I don't know. But I don't want to worry about any other parts of the graph, because we're talking about minimums. There could be a bunch of minimums. We just want the minimum in this amount of x values. Okay, and then let's talk about the y max. Maybe, what? Anybody have an idea? 5,000? Let's try it. Remember, you can always go back and change it. You're not stuck with it. Let's see what we see. And 5,000 is perfectly fine, okay? Because what you want to be able to see is, can we tell where it's going up, where it's going down, where the min is? Okay, that's all those questions are asking about, up, down, and the minimum, right? So let's look at choice A. Is the minimum amount between 5 and 6? So back to our second calc, and minimum is number 3. So go over towards where your minimum is. Remember, it does not have to be super perfect. And I get a minimum of my value. My minimum is at x is 6.63, right? My minimum is at 6.6. That's right. Is that between 5 and 6? No. Nope, can't be that. Okay. Visually, just looking at the graph, where are we decreasing? We're decreasing right here. Where are we concave down and decreasing? That would be from here to about middle, right? Because somewhere in the middle of there we switch to concave up. So let's see what this max value is and see if that number makes sense, okay? Because that's where it would start to decrease. So I'm going to do my maximum, which is number 4. Got to get back over there. So enter, somewhere on the other side of it, enter, yes. And that's 2.63. Ooh, okay. it does start decreasing at that value. Okay? Does it go to 4.64? Well, it probably does. I'm going to put a sign face because I think it does because it's somewhere in between my max and my min. Remember, my min is at 6 point something. My max is at 2 point something. It makes sense that that's 4 point something. I'm going to hold off on that. It is the answer, by the way. And then you can say, are we increasing, going up? Where are we going up? Where's the graph going up? It's going up over here, but that's not what it's talking about. It's also going up over here. And where is it concave down? Way over here. Well, 6.64 is here, not up here. This is concave up right here. It can't be this one. Using the information I found here, I know that this is not right. It can't be. It is not. It's increasing, but it's not concave down at 6.64. Okay? And then the last one, where we change from decreasing to increasing, where we go from going down to going up. That's a minimum. That's right here. We already know that. We just answered that in part A. It's not happening at 4.64. It's happening at 6.6. So there's my best answer. Okay? All right. It's a lot. Last question, the FRQ, which is not bad at all. The hardest part is typing a bunch of numbers in your calculator. Okay? So the question here we have is, table below shows the number of hours of daylight during 2022 for theme parks near Orlando, Florida. So they give us the months of the year, 1 through 12, and that's the numbers we'll use, right? From 1 to 12 to represent those. And then the hours of daylight in that month. I'm guessing it's an average. This is list 1 and list 2. Because what it's asking for is a sinusoidal regression. We see regression. That is going to be where we have our stat stuff, back where we did stat. So let's clear the RAM and go to stat. Okay? So remember where to go here? We're going to go to stat, edit, or just hit enter. And there's your list 1, list 2. Take a second and type in your numbers. Now, when it's the test, I would definitely take my time and make sure you're not getting any of those wrong. 1 through 12 is easy, right? But you can imagine it's easy to make a mistake here. So just be careful. You guys know how to text really fast? So think about it. Pretend you're texting. Okay. So once you do that, we go to stat again, just where we started. Remember, go across to calc at the top. And this is where you have to find sinusoidal. We've done a whole bunch of different ones in here. We never did that one. So if you scroll on down to the letter C, see how it says sine reg? That's the one we want. Enter. Enter, enter, enter. Get to store. Do we remember how to store? Alpha, trace, enter, and calculate. And it's so nice. It gives us the equation at the top, right? And then it tells us put A, B, C, and D right in those places. Plug them right in. And the directions here tell us to round to 3 decimal places. So it's really, make sure you round correctly. What letter is the midline? Because it's asking for the midline and then to explain what it means. What letter is midline? Which one? D. D. D is your midline, right? This one right here. So that's D. So our midline's approximately 12.072. That'll get you a point, but it won't get you all of the points for this question because you need to explain what it means. So think about what the middle is. It's your average, okay? So I'm not going to write it again. Let's put my key up here. So the midline is the average number of hours of daylight over the 12-month period. So it's approximately, the average out of all of those months is about 12.072. So in your own words, but you would want to explain what that midline means. Middle. So stat, calc, you're there. Okay, and then you're going to go down till you get to C, sine reg. That's sinusoidal. Actually, I don't even know if you need to store it. So you must have. I'll have to. Don't zero it out. I'll come over and look at it. If you didn't get these answers, is that what you're saying? Okay, so you probably have something. It means you have something wrong in your. Nope, not there. In here. So you have something wrong in here. You probably didn't go all the way down to 12 on one of them. Usually somebody leaves one of those off, so that's usually where the mistake is. But I'll look at yours. Don't clear it. Okay, last question. Use the table of values for June and July to find the AROC, average rate of change. Okay, so June would be month 6, July would be month 7. Okay, so the Y value for July minus the Y value for June, actually it doesn't matter what order you put them in, would be 1 or over -1. Either way, you get this many hours of daylight per month. Now, that's the answer, right? But explaining what it means, since it's positive, it's an increase of that many hours per month, 0.08 hours for the month of from June to July. Now, I would love to see you guys go further with it. Remember, I'm a pretty easygoing grader, but, you know, how can you interpret that? And, I mean, that we don't speak in terms of 0.08 hours, right? How much time is that? Well, if I multiply that by 60 minutes in an hour, I got 4.8 minutes. So that's in between June and July, we increase by 4.8 minutes of daylight. Who cares? Right? So that is your test. Again, bring your questions tomorrow. If you're here tomorrow because you're not skipping because it's SAT or whatever, bring your questions. I can work with you. We're not doing anything. But it's good to do it and see your mistake because then it's on your radar. You know what I mean?